Okay, students, we have to learn how to write a given fraction into its partial fraction. But before we do that, we need to recall that how are we writing two or three given fractions as a single fraction. Now, suppose you have a fraction which is 2 over x plus 1, and you have another fraction which is minus 5 over x plus 2. How can I write this as a single fraction? Yes? By
Take the
taking
LCM.
the LCM. The LCM is x plus 1 into x plus 2. So we have 2 into x plus 2 and minus 5 into x plus 1. Now, by the way, to learn this topic, partial fractions, you should be very good at this LCM thing, okay? Now, this is 2x plus 4 minus 5x minus 5 over x plus 1 to x plus 2. So this is minus 3x minus 1 over x plus 1 into x plus 2. Okay, this is what you have been doing a lot in your O-level mathematics. Now, the question is that you have been given minus 3x minus 1 over x plus 1 into x plus 2. And you are required to split this into its partial fractions. Like we want to go back to this thing over here. We want to know that what are these partial fractions? What were those fractions which were summed up to get to this one fraction? Okay, so now let's learn how to do that. First of all, you will always check that if this is a proper fraction. That will always be your first check. You should note it down that you will always check that if this is a proper fraction. If it is a proper fraction, fine. Otherwise, you will have to write it as a sum of a polynomial and a fraction, and then you will proceed. Okay, now we know that this is a proper fraction. Now, next thing that you have to notice is you have to see that if its denominator is fully factorized. If it is not fully factorized and you think that you can factorize it, you should. Now, this is already factorized. There are two factors. Now, the number of factors of this denominator suggest us that we can write this, we can split this one single fraction into two fractions. So you will suppose that those two fractions are a over x plus 1 plus b over x plus 2. Okay, so there are two factors. There are going to be two partial fractions. That is your first level of the partial fractions. Okay, now you will take the LCM and this will become this minus 3x minus 1 over x plus 1 into x plus 2. That is a into x plus 2 plus b into x plus 1. Okay, so I have just taken the LCM. Did anyone notice this sign over here? No one asked me that why I am using the identity sign over here. What is an identity? Look at this. Let me tell you. When you have, for example, there is
Only
2x
one.
plus 1 that is equal to 5. This is an equation, you can solve it and you can find your x as 2, okay? But if you have 2x that is equal to x plus x, this is an identity. Like one expression has been written in two different ways. Okay, so 2x is same as x plus x. So this is an identity. We cannot solve an identity. Identity means the left hand side and the right hand side are representing the same thing. Like for example, if I have 4 that is equal to 2 times 2, that is an identity. Okay, so if I write here 4x and this is going to be 2x, so this is going to be true for all values of x. When you solve an equation, you get a value of x, but identity is true for all values of x. If you keep x as 1, you will be putting x as 1 here. This is 2 into 1. So you see that that will be same as 1 plus 1. So 2 is equal to 2. So that is why I am using the identity sign over here, and you have to use it as well, because we are saying that this minus 3x minus 1 over all of this is same as this a over x plus 1 plus b over x plus 2. Okay? Now our mission is to determine the values of a and b. Let's do that. Okay? So now since this is an identity, so I can say that the left hand side is same as the right hand side. So I can compare the numerators. So I can say this minus 3x minus 1 is same as a into x plus 2 plus b into x plus 1. Now this is, since this is an identity, so I can use I can put anything over here. So I will intentionally put x equal to minus 2, because I know that x plus 2, I want this to be 0, x plus 2, so that this a is eliminated. Okay, so when I put this x as minus 2, all of this term will be gone. I'll only have b with me. So this is going to be minus 3 into minus 2 minus 1, that is equal to b into minus 2 plus 1. This is 5, that is equal to minus b. So your b is equal to minus 5. Okay, and then you will put x equal to minus 1, because I want to get rid of all of this. So if I put x as minus 1 over here, or I put x plus 1 equal to 0, I get x equal to minus 1. So I'll have only a with me. So this is going to be minus 3 into minus 1 minus 1. That is going to be a into minus 1 plus 2. So this is 3 minus 1, that is 2, and that is equal to a. Okay, so we got the values of a and b. If you compare these two over here, and you put your a as 2 and your b as minus 5, you see that we have got these two fractions back. Okay, got it, bacho? Yes.
Sir, we can also solve it by simultaneous equations. So why don't we do that?
This is totally up to you. This is the shortest way of doing it. You can even compare the coefficients. I'll be telling you in the later questions. Okay? Okay? Okay. I'm going to remove this. Please look at this, and if you have any question, please ask me.